How did the first living thing on Earth actually become a living thing? Was there some divine power that breathed life into it? Or was it an alien that came to Earth to live? And after observing for a few weeks, they saw something astonishing. This led to the birth of single-cell organisms, which later evolved into living beings. Life did not begin on Earth, it started in space. Hello friends, did you know that your DNA is 60% similar to that of a banana? No, I'm not joking. This is a fact. Humans and bananas share a common ancestor. If you go far back in time, around 100 million years, you will find that the ancestors of humans and bananas were the same. In fact, this is not just true for bananas, but for all animals and plants on Earth. If you go even further back, about 3.7 billion years, you will find that all living organisms on Earth share a common ancestor, LUCA. LUCA stands for the Last Universal Common Ancestor. It was a single-cell organism, a microbe that scientists believe thrived in hot environments. Every living thing on Earth today, whether plants, animals, fungi, algae, or bacteria, has evolved from LUCA. However, LUCA was not necessarily the first living organism on Earth. There were likely many living organisms before it, but scientists don't know what they looked like. In fact, they don't even know what LUCA looked like. But the important question is, how did LUCA come to life? How did the first living thing on Earth become a living being? Was there a divine force, or did an alien come to Earth? This is the mystery of the origin of life. How did non-living matter, rocks, soil, water, and chemical elements, transform into living organisms? Let's explore this mystery in depth in today's video. This is my 5th video in the evolution series. I have already made 4 videos before this. 1. The theory of evolution. 2. How humans evolved from apes. 3. Which came first, the chicken or the egg. And 4. How was Earth formed in the solar system? Now in this 5th video we will discuss how non-living things transformed into living beings. It sounds unbelievable, and even scientists used to believe that a special life force existed within every living thing, keeping it alive. However, in 1780, French chemist Antoine Lavoisier conducted an experiment that suggested that living and non-living things might not be so different. He took a guinea pig and measured its body heat by observing how fast it melted ice and how much carbon dioxide it released. He then compared it with a piece of coal, which released the same amount of carbon dioxide and melted the same amount of ice. His conclusion, both living and non-living things operate under the same chemical principles. A decade later, in 1790, Italian scientist Luigi Galvani was working with dead frogs. He had hung the frogs' legs on brass hooks and by accident touched them with a steel blade. To his surprise, the legs twitched. Galvani thought he had discovered the life force and called it animal electricity. However, Alessandro Volta later disproved this theory, showing that the movement was caused by an electrical reaction between the two metals, not by any life force. Volta later used this principle to create the first electric battery. The term voltage comes from his name. Despite these discoveries, people still believed that life contained some special energy not found in non-living things. The key reason behind this belief was that living beings contain chemical compounds such as fats, proteins, and sugars that are not found in non-living things like rocks and soil. This led to the birth of organic chemistry. Why is chemistry divided into organic and inorganic branches? Because organic compounds are primarily found in living beings, while inorganic compounds are found in non-living things. Scientists assumed that organic compounds could only be made by living things, meaning some life force was at work. The turning point came in 1828, when German chemist Friedrich Wöhler accidentally created an organic compound from an inorganic one. He synthesized urea from ammonium cyanate, the same compound found in human urine. This experiment shocked everyone and proved that organic compounds could be formed through chemical reactions without any life force. In 1850, Parisian chemist Marcellin Berthelot took it further, launching a total synthesis program. He declared that he could create all organic compounds using only carbon, hydrogen, oxygen, and nitrogen, and he succeeded. First, he created hydrocarbons, then converted them into alcohols, then esters, and eventually organic acids, all through chemical reactions. By this point, scientists accepted that organic compounds could be synthesized without a life force, but they still wondered, if organic compounds alone are not alive, then where does life come from? Defining life became essential. Does being alive mean being able to move? If so, animals qualify as living, but plants do not. But we know plants are living. Does life mean the ability to reproduce? If so, then plants, animals, and bacteria all qualify. But what about mules, which cannot reproduce? They are still living beings. In 2011, biophysicist Edward Trifon examined life's definitions and found 123 different ones. However, the common consensus was, life is self-reproduction with variation. This definition includes organisms that were born through reproduction, but cannot reproduce themselves. However, to truly understand how non-living things became living, we must examine the key differences between them. 1. Complexity. Living things are more complex than non-living things. 2. Metabolism. All living things need energy to survive, whether animals eating food, plants absorbing sunlight, or bacteria using environmental nutrients. 3. Boundaries. Living organisms are separated from their environment by a barrier. Skin for humans, cell walls for bacteria. 4. Reproduction. Living things can replicate themselves through DNA or RNA. The transition from non-living to living did not happen suddenly, but gradually over time. Where did life's building blocks come from? Some scientists believe they came from space, a theory known as panspermia. Evidence supports this claim. Spectroscopy has shown that complex molecules exist in space. Since 1930, scientists have discovered simple molecules like cyanide and ammonia in interstellar gas clouds. In 1969, a meteorite that fell in Australia contained over 20 amino acids. Later, scientists found organic molecules like urea, glycine, and even ethanol in space. In 2014, they discovered isopropyl cyanide, a molecule crucial for forming amino acids in a molecular cloud 25,000 light-years away. DNA and RNA, essential for life, contain sugars like ribose. In distant gas clouds, scientists have found simpler sugars that can form ribose. This suggests that space holds the chemical ingredients for life. The primordial soup hypothesis suggests that on early Earth, a warm pond contained a mix of inorganic molecules. When exposed to lightning and volcanic heat, these molecules formed the first organic compounds. In 1953, Stanley Miller and Harold Urey tested this idea. They filled a large glass container with ammonia, methane, and water vapor, simulating Earth's early atmosphere. Then they passed electrical sparks through it to mimic lightning. The result? The formation of amino acids, the building blocks of life. This experiment showed that life's ingredients could form naturally under the right conditions.